Good morning, everyone. I am Shanza Hussain. I am currently studying in D1 second year. Today, my topic of discussion is anticholinesterase drugs. It is guided by my teacher at the university. So, what do you understand by anticholinesterase drugs? What is the definition of anticholinesterase? It is a topic in the subject of pharmacology. Anticholinestrases are drugs that increase level of acetylcholine after it is released from cholinergic nerve endings by inhibiting acetylcholinesterase. Acetylcholinesterase is an enzyme. Cholinergic drugs are divided into two broad categories that are direct acting and indirect acting. Acetylcholine is a type of a neurotransmitter. Acetylcholinesterases are mostly called as enzymes, and anticholinesterases are those drugs that inhibit acetylcholinesterases. So this is the definition, and it comes under the classification of cholinergic drugs. The next, I am going to explain the mechanism of action for anticholinesterases. It is almost very similar to cholinergic drugs mechanism of action. So here we can start from the box 1, where it is written synthesis of acetylcholine. So the choline, it is transported from when the action potential is generated. The choline is transported and made as acetylcholine. Second is uptake into storage vesicles. Acetylcholine is protected from degradation in the vesicle. It is kept in the vesicle so that it cannot be degraded. The third step is release of neurotransmitter. Acetylcholine is a neurotransmitter. Release is blocked by botulinum toxin. Spider venom causes release of acetylcholine. So here spider venom can be called as a catalyst which releases the acetylcholine. Fourth step is binding to the receptor. Postsynaptic receptor is activated by binding of the neurotransmitter. Now we have two types of nerves. First is presynaptic, second is postsynaptic. So postsynaptic is activated when the blue color ball of acetylcholine is binded with the receptor. The fifth point is degradation of acetylcholine. Acetylcholine is rapidly hydrolyzed by acetylcholine esterase in the synaptic cleft. Now between two neurons there is always a junction. A junction can be called as the gap, that is known as synaptic cleft, and in that synaptic cleft there is always an enzyme that is present, that is called acetylcholine esterase. It helps to hydrolyze acetylcholine, and it hydrolyzes to form choline and acetate. The sixth point is recycling of choline. The leftover choline is recycled and taken back by the presynaptic neuron. So that was the mechanism. I have also mentioned the reference of the slide. So this is the basic mechanism of cholinergic drugs and anticholinesterases also. Next, we move on to classification. Classification is same as cholinergic drugs. Cholinergic drugs are classified into two types: cholinergic agonists and anticholinesterases. Anticholinesterases are inhibitors of acetylcholine enzyme, acetylcholinesterase enzyme. Now, cholinergic agonists are of two types: choline esters, alkaloids, cholinesters and alkaloids. And anticholinestrases are of two types, reversible and irreversible. One is carbamate, another is acridine in reversible, and in irreversible there is also carbamates and organophosphates. The example of these can be studied from the book itself, and maybe I have included them in the next slides. Next we come again back to mechanism of action. The mechanism of action, now I am explaining it with the help of theory that was explained with the help of a diagram. Now this is explained with the help of a theory. So here ACH is acetylcholine. ACH is inactivated by combining with the enzyme acetylcholinesterase. ACHE is acetylcholinesterase at two sites, anionic site and esteratic site. Here anionic site and esteratic site, we are talking about the structure of acetylcholinesterases. In that there are two types of sites. One is anionic site that you can see in crescent moon shaped, and the other one is esteratic site that can be seen as curly braces shaped. So the acetylcholine that is in the benzene ring shaped, nitrogen N positive reacts with anionic sites, and OH reacts with esteratic site. So this is how ACH is activated by the enzyme acetylcholinesterase. Now we come to the mechanism of action. Here I have already given the equation. So first let me read the equation. Acetylcholine plus acetylcholinesterase gives acetylcholine enzyme complex, which gives acetylated enzyme plus choline. Then that gives choline plus acetic acid plus free enzyme. So at the end we get choline, acetic acid, and the enzyme is again free. Acetylated enzyme reacts with water extremely rapidly, and the esteratic site is freed in a fraction of milliseconds. So people, you can understand that this reaction is happening in just a millisecond. Carbamylated enzyme reacts slowly. Phosphorylated enzyme reacts extremely slowly. So here they are telling us about the reversible and irreversible classification that we have studied before. Here we can see acetylcholinesterases are divided into reversible and irreversible. In reversible and irreversible, there are carbamates and organophosphates. So the same thing here, it is written carbamylated enzyme reacts very slowly for reversible, and phosphorylated enzyme reacts extremely slowly for irreversible. So now next I continue my mechanism of action. Here you can see reversible anticholinesterases and irreversible anticholinesterases. Now firstly, reversible anticholinesterases combine with anionic and esteratic site of acetylcholinesterase. They produce carbamylation of esteratic site. So that's what we were saying about the carbamylated enzyme in the last slide. Here we were talking about the carbamylated enzyme in the last slide. Now irreversible anticholinesterases combine with esteratic site of acetylcholinesterase ACHE produce phosphorylation of esteratic sites, irreversible inhibition of enzyme. So in irreversible and irreversible there is a difference. Enzyme is inhibited temporarily, and here in irreversible enzyme is inhibited irreversibly. So now we move on to the next slide. We now come now we have we can say we have known about the classification, the mechanism of action. Now we will see the pharmacological action of acetylcholinesterases. Pharmacological action means the action that it produces in the body. Uh, Pharmacological action can be of two types, that can be pharmacodynamics and pharmacokinetics. Here we are studying the pharmacological actions on different parts of the body. Here there are two types, lipid soluble. Lipid solubles are mostly physostigmine and organophosphate. Their action on skeletal muscles is very less. For lipid insoluble agents, neostigmine and quaternary ammonium compounds more effect on skeletal muscles. So here lipid insoluble have more effect on skeletal muscles than the lipid soluble one. Now we will see the pharmacological actions on the different parts of the body. So first part is ganglia. High doses cause persistent depolarization, also blockade of transmission. Ganglia is present in the nervous system. Cardiovascular system effects are complex. Muscarinic acid action produce bradycardia and hypotension, but ganglionic stimulation tend to increase heart rate and BP. For CNS, produce generalized alerting response. In Alzheimer disease, cognitive functions are improved. Higher doses produce excitation, mental confusion. For skeletal muscles, ACH, that means acetylcholine, rebinds to same receptor twitching. Force of contraction is increased. Higher doses cause persistent depolarization. So here we are repeatedly seeing the word persistent depolarization. So in persistent depolarization means that persistent means back to back, and depolarization we all know from the mechanism of stimulus that depolarization happens. So back to back depolarization will be happening because of high doses, and the transmission will be blocked. Cardiovascular system effects are very complex because muscarinic action will produce bradycardia, that is lesser heartbeat and hypotension, but ganglionic stimulation they will increase the BP and heart rate. Similarly, CNS will produce alerting response and cognitive functions will be improved. And for skeletal muscles, force of contraction will be increased. So that was all about the pharmacological actions on the various systems of the body. Next up, we will see about the pharmacokinetics. That was the pharmacodynamics, pharmacological actions. Then there will be pharmacokinetics. Kinetics means movement. So how the drug moves in the body, that will be studied. Here we are studying mainly about two specific drugs, that is physostigmine and neostigmine. Neostigmine and physostigmine both can be given from different routes of administration. Here physostigmine is rapidly absorbed from GIT. It penetrates cornea freely. It crosses BBB. BBB is a blood-brain barrier. Bimiotic is the drug which contains 0.25% eye drops and 2% pilocarpine nitrate. For neostigmine, poorly absorbed orally, do not penetrate cornea. Neostigmine doesn't penetrate cornea. It cannot cross BBB effectively. Prostigmine, myostigmine, tilstigmine 15 mg tab, 0.5 mg per ml in 1 ml and 5 ml injection. So it comes in tablets and injections both. Now last but not the least, uses where anticholinestrases can be used. So firstly, anticholinestrases drugs can be used in glaucoma. Glaucoma is a condition of eye. It is an eye disease in which the person could not become blind because of damage of optic nerve. So it is used as a miotic. Next is in myasthenia gravis. Myasthenia gravis means also a disease of eye, and then it can be used in cobra bite. If a snake bites you, then neostigmine plus atropine, they both prevent respiratory paralysis. So you will be saved from respiratory paralysis. Next, it can be used in belladonna poisoning. Physostigmine IV injection, in IV means intravenous injection, can be given in belladonna poisoning. Next, it can be used in Alzheimer's disease, because we have studied in pharmacological action that it increases the cognitive abilities. Next, cerebroselective anticholinestrases, anti-CHEs is anticholinestrases, rivastigmine, donepezil, and galantamine. Next, uh, anticholinestrases poisoning antidotes are atropine and oximes. Anticholinestrases poisoning is basically the poisoning done by organophosphates. Organophosphates are used as pesticides and insecticides in the general market, for example, HIT or any pesticide that is used in farming. So it can be possible that it is not used properly and there is a poisoning, so that is called as anticholinesterase poisoning. So the antidotes preferred for that is atropine and enzymes. Atropine and enzyme oximes are the drugs that are drug of choice used in anticholinesterase poisoning. Thank you everyone for listening patiently to me. See you next time.